In this lecture, we will talk about finding exact solution of a second order ordinary differential equation. And the special thing about the ordinary differential equation which we will take as an example, its characteristic equations are going to have identical roots. So let's take the example of y double prime plus 4y prime plus 4y is equal to 10t. Initial conditions are given as y sub 0 is equal to 5, y prime of 0 is equal to 2. Now we know that if we're going to solve it by the classical solution techniques, that the full solution will be equal to the homogeneous part plus the particular part. Let's go and look at the homogeneous part, how we're going to calculate that. Homogeneous part meaning that it is the solution to the differential equation with no forcing function. So you would have no 10t in there. So let's see what the solution will be. For that, what we do is we calculate the characteristic equation, which will be, hey, this is second derivative, so it's m squared. This is first derivative here, so it will be 4m, 4 being the constant there. And this is zeroth derivative, so it will be just 4, and put that equal to 0. Now we can solve this particular quadratic equation by either doing the factoring, which is m plus 2 whole square equal to 0, hence implying m is equal to minus 2 and minus 2. Or what you can do is you can solve it by using the quadratic equation, which will be minus b, which in this case is minus 4, plus minus b squared, which is 4 squared, minus 4ac divided by 2 times a. And if you look at this one gives you minus 2 and minus 2 as well. So we have two roots of the characteristic equation, minus 2 and minus 2. So that gives us the homogeneous part of the solution will be of the form k1 e to the power minus 2t plus k2 e to the power minus 2t. But since it's the same as this one, we have to choose the next independent solution corresponding to the second root of the characteristic equation will be k2t e to the power minus 2t. So we have found the homogeneous part. Let's concentrate on the particular part. The particular part of the solution will look like the form of the right hand side and all its possible derivatives. So in this case, it is 10t is the forcing function. So it will be the form will be a times t, and then the derivatives of a times t is a constant, let's suppose a. So we'll write as b. So that is the form of the particular part of the solution. If that is the case, now how do we find out a and b? We find out a and b by just saying that, hey, let's put that back into the differential equation. We have y double prime plus 4y prime plus 4y equal to 10t. And what we're going to do is we're going to plug it back in here. We'll get second derivative of this quantity, first derivative of the quantity, the assumed solution, plus 4 times the assumed solution is equal to 10 times t. So if we solve that, we get 0 from the first term, we get 4a from the second term, and we get 4at plus 4b from the last term is equal to 10t. Now here we have two unknowns and only one equation, but we know that if we equate the coefficients of the left hand side and the right hand side, we will be able to set up two equations, two unknowns. So what I mean by that is that let's isolate the terms of t, which is 4a times t coming from here, and the constant terms of 4a plus 4b. And on the right side we have 10 times t, so this 10 will be equal to 4a because the terms have to match. And then let's put a 0 here so that we can say, hey, this will be equal to this. We get 4a times t is equal to 10t. I shouldn't write it like that. I should simply say the coefficients of the t to the power 1 term are equal. So 4a is equal to 10. and 4a plus 4b is equal to 0. So we have two equations, two unknowns, and those can be solved easily. This one will directly give you a is equal to plus 2.5, right? And then this one will give you 4 times 2.5 plus 4 times b is equal to 0. That is the second equation. And that will give you b is equal to minus 2.5 from there. So those are the two unknowns which we have from there, which tells us that the particular part of the solution will be 2.5 times t minus 2.5. So we've done that part. We've found the particular part exactly, and we have found the form of the homogeneous part. And now what we're going to do is, in the complete solution will be equal to the homogeneous part plus the particular part, as we said. The homogeneous part is as follows. And the particular part which we just found out is as follows. So the only thing which is remaining is that how do we find K1 and K2, and we find those by using the initial conditions. So the initial condition here is y sub 0 is equal to 5. So let's plug that in. We get 5 equal to K1 e to the power minus 2 raised to the power 0 plus K2 times 0 e to the power minus 2 times 0 plus 2.5 times 0 minus 2.5, and that gives me K1 here, gives me a 0 here, a 0 here, and minus 2.5, and that eventually gives me K1 is equal to 7.5. So I've at least found out what K1 is. So let's go and find out what K2 will be. For that case, we know that y prime of 0 is given as 2. So if y prime of 0 is given as 2, what does that mean? That means that our y prime will be the derivative of our current form of our solution. And this one will give us minus K1, 2K1 e to the power minus 2t. This part has to be done by differentiation by parts, not differentiation by parts, differentiation of product of two functions. So that will give you K2 e to the power minus 2t and minus 2K2t e to the power minus 2t. So that is coming from differentiating this part. And then differentiating this part gives you 2.5, and differentiating this part, of course, gives you 0. So having said that, then let's go and see what this gives us. So what we have is that y prime is now given as this quantity right here. So y prime of 0 is 2. So that means 2 is equal to, by putting in the value of t equal to 0, let's see what happens. So we get 2 is equal to minus 2K1 plus K2 plus 0 plus 2.5. And now we have 2 is equal to minus 2K1. And let's see, yeah, we already know the value of K1. So K1 is how much? 7.5. We want to find out what K2 is. And from here, we'll find K2 is equal to 14.5. So we have found K1 and K2, so we have a complete solution available to us. So y will be equal to YH plus YP, and we have found out it to be, I don't need to write that down because I already wrote that down. So let me just write down y we had as K1 e to the power minus 2t plus K2t e to the power minus 2t plus this quantity here. So we found out K1 is equal to 7.5. We found out K2 is 14.5. And so that becomes our complete solution. And that is the end of this segment. Thank you.